All right, now starting the second part of the quadratic functions section. So we're still in section 3.1. We're going to keep going with graphing quadratic functions. Last time we graphed them using transformations, so we needed to put it into vertex form. We also found the x and y intercepts. Today we're going to identify the vertex and the axis of symmetry just using standard form, graph the quadratic functions using the vertex, the axis, and the intercepts, and then use the maximum or minimum value of a quadratic function to solve applied problems. So that third one is one we're going to do more in class. The first two I'm going to talk about in the video today. If you have your handout, or if you want the handout to take notes, don't forget that you have that option if you want. All right, so just kind of a quick refresher that we talked about last time. So here we have quadratic function in the form ax squared plus bx plus c. That was standard form. And we also have vertex form, where the quadratic is in the form a times the quantity x minus h squared plus k. Last time we were able to get the function in vertex form by completing the square. Today we are going to just focus on looking at functions in the form, in standard form, and graphing it from there without putting it into vertex form. So we have this function f of x equals negative 3x squared plus 12x plus 1. So the first thing we're going to do is we're going to figure out what the axis of symmetry is. So when we're graphing by hand without completing the square, you first need to find the axis of symmetry. Quadratics are always symmetrical, so the axis of symmetry is that'll be right down the middle of your parabola. So the way we do that, and I don't know if any of you guys remember this from Algebra 1 or Algebra 2, that formula x equals negative b over 2a. So this will always find us the axis of symmetry. So our b value is 12. So negative 12 over 2 times a, which is negative 3. So negative 12 over negative 6, which is 2. So our axis of symmetry is x equals 2. So we know that the center of our parabola is going to be at x equals 2. The other thing that is at the center of our parabola is the vertex. So if we want to determine the vertex, we know that our vertex will have to lie on that axis of symmetry. So the x value of our vertex has to be 2, since that will always be in the middle of our parabola. The x value of the vertex is always the same as the axis of symmetry. So what we're going to do there is we're going to plug 2 in to our function. So we plug in 2 for x, we can solve and figure out what y is. So that'll be negative 3 times 4 plus 24 plus 1, which is equal to 13. So our vertex is at 2, 13, right there on our axis of symmetry. So we got our vertex. That's our most important point of our parabola. Same thing when we're in vertex form, we always find that vertex first. It's just two different ways to do it. Vertex form, you already know what the vertex is. Here we have to use that axis of symmetry to find it. But once you have the vertex, you have to find your points on either side of the parabola. Well, right now we don't know what the transformations were. We don't know what that rate of change was. So the first thing we're going to do is determine the y-intercept. So do you remember how to find the y-intercept from the standard form equation? Y-intercept, since you plug in 0 for x, is just going to be the c value in your standard form equation, because plug 0 in for x and you just get 1. So 0, 1 is our y-intercept. The next thing we could do is either pick points and just plug them in for x to see where they are. The easiest thing to do, though, is we know that a parabola is symmetrical. So if I have one point on one side of the axis of symmetry, I know I have to have a point directly across from it on the other side of the axis of symmetry. So if I have the point 0, 1 here, I'm going to have the point 4, 1 on the other side, since a parabola is always symmetrical. So once I have those 3 points, then I can draw the graph. So just make sure you make it curved. You know that the quadratic always has to have that parabola shape. So when you only have 3 points, you just want to make sure you have that curved shape. All right, so that's graphing by hand using standard form without putting it into vertex form. All right, so take a look at this quadratic function. This is going to be a little bit of review and a little bit of taking what you have done before. So quadratic function, negative 2x squared plus 8x plus 3. Right now I want you to pause the video and answer these 10 questions about this graph without graphing it. Do not put it in your graphing calculator. Do not graph it by hand. I just want you to see if you can look at the function and figure out these 10 things about the function. So go ahead and pause the video right now and do that on your own. When you are ready, play the video and we'll talk about the answers. Okay, so you should have answers for all 10 of these questions. So let's talk about them. Opening up or down. How do we know that? Well, if you look at just like in vertex form, our A value determines if it opens up or down. If it's negative, it's going to open down. If it's positive, it's going to open up. So, whoops, already I have the wrong answer. So, that should be opening down because it's negative. Okay, so we're going to have to change a few of these. All right, is it a maximum or a minimum? Since it's opening down, we're going to have a maximum value. So the parabola opens down. Somewhere. So our vertex is the maximum point on the graph. Our axis of symmetry was x equals 2. So you should have found that by doing x equals negative b over 2a. So negative 8 over 2 times negative 2 was going to be 2. The vertex, plug that 2 back into our function, and you got a vertex of 2, 11. Y-intercept, again, when you plug in 0 for x, you get 3. So always that c value in our standard form function. The x-intercepts, we practiced this a little bit last video. So we have 2 plus or minus the square root of 22 over 2 is how you got your x-intercepts. And if you weren't able to get that, try again. If you're still not able to get that, please make sure you circle that, write it down, and ask me in class next time. And I will be happy to show how I got that. The domain, okay? A parabola is always the same, okay? Parabola always goes on forever both ways on the x's. So for a quadratic function, our domain will always be from negative infinity to infinity. The range, however, since this is a parabola that opens down and has a maximum point, the maximum point is at 11. So the highest this parabola goes is 11. But it opens down, so it continues on forever to negative infinity. So the range on the y's is from negative infinity to 11. So you should not have to graph that to know that, because you know a quadratic is always a parabola. You know what a parabola looks like. You know that it's opening down, so it goes to infinity, and you know where the vertex is, so you know the highest point it reaches. You shouldn't also have to graph it to do the increasing interval. You know, since it opens down, it's increasing from left to right. So from negative infinity to 2, which is where the vertex is, where the axis of symmetry is. The middle of the parabola. So from negative infinity to 2, which is the middle of the parabola, and then it's decreasing from 2 to infinity. Okay. All right, good. Cool. So now that we practiced that a little bit, let's just do one more example where we're graphing by finding the vertex, the axis of symmetry, and the y-intercept. Again, if you felt pretty good about the first example where we did this, you are welcome not to do this example. You are also welcome to do it with me as a little bit of extra practice. I have put a couple more problems at the end that are optional practice that you'll be able to work on if you choose to, if you feel like you need a little bit more practice with this before you come to class and work with the rest of your group. But let's first do this one together if you would like to follow along. So we have the equation f of x equals 2x squared plus 4x plus negative 4, or minus 4. I don't know why I put both of those there. Okay, so the first thing we want to do when we're graphing it by hand and we're not putting it into vertex form, we need to find the vertex. So our axis of symmetry is first and foremost. We have to find where the center, that middle of that parabola is. So x equals negative b over 2a. So negative 4 over 2 times 2. So x is equal to negative 1. So our axis of symmetry is at negative 1. Now we know about where the center of our parabola is. To keep going and find the vertex, we need to plug in negative 1 for x because we know that our vertex will lie on the axis of symmetry. So the x value of the vertex has to be negative 1. So let's plug it in and figure out what y is. Plug in that negative 1, and we get negative 6. So our vertex is at negative 1, negative 6. All right, once we have that crucial center of the parabola, we need to find a couple of other points. So the easiest point to find is that y-intercept. Because we know when it's in standard form, our y-intercept is just the c value in standard form. So negative 4. 0, negative 4 is our y-intercept. Since a parabola is symmetrical, if I have that point on the right side, 0, negative 4, I have to have negative 2, negative 4 on the other side. Once you have your points plotted, go ahead and make sure you do that nice curved parabola shape. And there you go, graphing a parabola using the vertex, the axis of symmetry, and the y-intercepts. So if you would like to practice a couple of more, just to make sure you have it down before we work on it in class a little, go ahead and in Interact Math, try doing exercises 41, 43, and 47, graphing it on graph paper